Next one, we're asked to find out the mean and the standard deviation given the summary data. And I mean, you don't need a formula book to remind you that the mean is you add up all the x's and divide by n, how many there are. So we've got 316 divided by 20, and we can tap that in the calculator to get 15.8. Now, it might take a bit more memory to remember the standard deviation formula. Now, the standard deviation formula is the square root of the sum of the x squareds divided by n minus the mean squared. And that's in your formula books. You haven't got to remember it, but you do it so often, you should do. So it's 5078 divided by n, which was 20, minus the 15.8 squared. Let's see if we can do that. So we've got the square root of, what did I say, 5078 divided by 20, minus the square roots continuing, just make sure I did that, 8 squared, and so that's getting me 2.06 as my standard deviation. Continuing part B, without any more calculations, say how you think an extra wingspan will affect the mean. So this extra bird had 13 centimeters. So if it's 13 centimeters, it's smaller than the mean. So the mean would go down. The mean would decrease, wouldn't it? And part C. So the giant ibises, I don't know what they are. I'm going to look them up after I've done this. Their wingspans are also measured in a centimetre, and the following summary statistics were found. Right, so we've got coded one again here. But simply, let's just find out the mean of the z's first of all. So the mean of the z's is add up all the z's and divide how many there are. So that's 104 divided by 20. 104 divided by 20 is going to be 5.2. I knew that, 5.2. But actually, the z values were y take away 5 divided by 10. So I've got 5.2 times by 10, 52. Add the 5, the mean of the actual ones are going to be 57 as we work through that. And the standard deviation, we've given us the other notation here, and I apologize that there's so many different notations, but the standard deviation is simply the square root of SZZ divided by n. So what have we got here? 1.8 divided by 20 square rooted. Square root of 1.8 over 20 gives us 0.3, standard deviation of 0.3. Again, remember how we're going to use this coding. So the standard deviation here will be the standard deviation. The -5 will have no effect on it because it's just translating it down, divided by 10 here. So the standard deviation of the y's will be 3, just that 1 times 3.